Hello everyone, my name is MD Samad and I study in Michigan State University, and today I'm going to do a project of integral test for my Cal 2 class, that is Math 133. So for this project I was assigned two questions based on integral test. Number one is determine if this series converges or diverges. So for this one we will do the integral test. So this is positive, this is continuous from, and this will decrease over time. So for this one we can say we can do integration. So this will go from 1 to infinity ln of n over n dn, and then here we can take we can do the u substitution method. So we can take u is equals to ln of n. So if we differentiate the u, we can say that I can write over here du over dn is equals to 1 over n, since the differentiation of ln of n is 1 over n. So here we can say 1 to infinity, the integration goes 1 to infinity, and u into n dn over n, and from here n cancels out, so we are less, oh sorry, du, yeah, so we left with 1 to integration 1 goes from 1 to infinity u du. Yep. So now we can do the normal integration, that is this will become u square over 2. It goes from 1 to infinity, and then so if we plug in like infinity on like u, it will be infinity whole square over 2 minus 1 over whole square. So if we like subtract anything from infinity, this will still be infinity, so the answer will be infinity. Hence this series diverges. Okay, so we are done with question 1, and for the second question is it's a true and false question. So the integral of 1 over x cube goes from 1 to infinity, and the series n series okay sorry 1 over n cube both converge or diverge. So the second question is true or false question. So the integral 1 over x cube goes from 1 to infinity dx, and the series 1 over n cube goes from 1 to infinity both converge to the value of 1 or 2 or not. So for this one, first we will take the integral of 1 over x cube. So 1 over x cube, so we can write 1 over x cube as x to the power negative 3. So if we like dx, so if we integrate it, this will be x to the power negative 3 plus 1 over negative 3 plus 1 goes from 1 to infinity. So this will become x to the power -2 over -2. So we can also write this as -1 over 2x square, going from 1 to infinity. So if we plug in the values in that equation, we will get -1 over 2 infinity whole square minus -1 over 2 into 1 whole square. So 1 over infinity is 0. So, and then here negative and negative will become positive, so it will be, the answer will be 1 over 2. Yeah. And for the second part, that is what's that, if this series converges to yeah, if this series converges to 1 over 2, so for that we can take n equals 1, this goes to infinity, 1 over n cube. So we can take the limit comparison test here. We can take the limit of this, so it will be limit n goes to infinity 1 over n cube. So if you plug in like infinity in place of n, so it will be 1 over infinity cube. So as I told you, 1 over infinity is 0, so it will be 0. So this converges, but this does not converge to 1 over 2, so the answer will be false, as the first one like converges to 1 over 2 over here, but the second one doesn't converges to 1 over 2, it converges to 1 over 0. It converges to 0. So the answer to this question, the integral 1 over x cube going from 1 to infinity dx, and the series 1 over x cube 1 over n cube both converges to the value of 1 over 2, is false.